Hi everyone, greetings to our respective lecturer and good day to all our fellow viewers. We are a group of manufacturing engineering students from the University Technical Malaysia Melaka, hereby representing our team to present about the life cycle assessment of our chosen product for the assignment. Before we get into the project or presentation, I would like to introduce myself, Sathiyah, as the first presenter, while my teammates are followed by SURENTHIRAN, DALGLISH, Elizabeth and Muhammad DIENI IZZLY, those who will be taking turn to present their parts in this presentation. Without wasting time, let's begin into the presentation. While looking into the content of our presentation, there is a 6 main elements to be discussed in this video actually. Those are introduction, literature review, methodology, the results, discussion and conclusion. All these 6 elements will be discussed by our teammates sequentially, and as a first presenter myself, I will be presenting the introduction now. As for the first part, introduction, is all about introducing which product we have actually chosen for the report and presentation actually, and I will be presenting about the scope, aim and also the objective of our report. The chosen product for our report and presentation is actually an electrical kettle. The purpose of us choosing this electrical kettle as our product is due to the material characteristic as well as the compatibility of this product. Not only that, it is also having the ease of converting this material to be a sustainable product in future. Moving on to the background actually illustrates about the product lifecycle management, which says to be the strategical method to analyze on how sustainable a material can be survive in the market in future. And it also illustrates about the DFMA and DFE, which is a two different tools that used to analyze and calculate the sustainability level of a product. For an example, if we want to analyze or we want to measure the sustainability level of this electrical kettle, we can perform the DFMA or DFE tools in order to get the accurate data about the sustainability. In this slide, we have actually attached the actual picture of our chosen product, which is electrical kettle, as well as we also attached two different illustration pictures that shows that schematic drawing of our actual product and the exploded view of the actual product. The schematic drawing is essential in the way of labeling and tracing the parts location, and the exploded view helps us in order to trace how many parts there to be needed in the way of constructing a complete electrical kettle. Moving on to the core part of the introduction, that we have actually list down all the aims, scopes and objective of this project, which is the aim of this project is to assess the manufacturing and environmental impact of the electrical kettle process and to improve the linkage and between the economic and environmental systems. These are the aim of this project. As for the scope, the main scope is all about to determining the electrical kettle's life cycle. This is the scope that we have stated over here. And for the objectives, there are 4 objectives that we have to be focused on, which is to determine the life cycle of the electrical kettle and to analyze the eco-web design of each part of the electrical kettle, to analyze the environmental impact of the electrical kettle using eco indicator, and the last one is able to link the importance of DFMA and DFE. These are the objectives that we have stated over here, and that's all from me. Thank you.
Hello everyone, I'm Surenthiran. Today I'm going to discuss about the electric kettle's literature review. Let's look on history of electric kettle. The first kettle was made by Mesopotamians on 2500 and 3500 BC. The kettle was made by bronze with ornate spots. In early 19th century, the kettle was made by iron, where it uses open flame to boil the water. But the method was ineffective and time consuming. Since that, the kettle was made by copper, where copper can transmit heat more effectively than iron. In early 20th century, whistling kettle has emerged the market, where it was a significant step for the history of kettle. The rush of steam penetrates through the hole at the top of kettle, where it produces a whistling sound to notify the people around there. In 1891, the Carpenter Electric Company has produced some electric kettles, but it was failure due to their design. In 1920s, Swan Company has produced electric kettle with addressing the boiling problems, where they keep the metallic heating element inside the electric kettle. The electric kettle was successful, and the idea was the fundamental for the current electric kettles. Okay, let's we look on patterns of electric kettle. Let's we look on this pattern. This pattern is EP159798-9B1. This pattern indicates this is an intelligent electric kettle. This intelligent electric kettle consists of heating element and sensor. When the temperature of the water sensed by the sensor is equal to or greater than the cutoff temperature, the control unit is configured to turn off the power automatically. Okay, let's we look on this pattern. This pattern is US840500-4B. In this pattern, a vessel is included in the kettle as well as a bottom housing. At the base of handle, there is a power switch with an internal LED light. When the cold water is fully or partially filled in the vessel and then the switch is pressed, the electricity is communicated to the heating element. The PCB will turn on or both LED, causing them to light up. As the water temperature rises, then it sends signals to PCB which activates another indication light once the temperature has reached on a certain level. When the thermistor detects boiling, it will send a signal to PCB which turn off the electric heating element. That's all from me. Thank you so much.
Hi. Okay, now I gonna present about the methodologies. There is four parts, which is life cycle thinking, eco web design, eco indicator, and also material analysis and their life cycle. The first one is life cycle thinking. The implementation of this life cycle thinking is essential for the assessment as it really contributes on several aspects like below. First, to assess the product's entire life cycle from its initial conception to its end. The second is concentrating on the production side and manufacturing process as well the product's environmental, social, and economic impact. The ultimate goal of this LCT, or also life cycle thinking, is to raise people's and industry awareness of how their action harm the environment by reducing the number of resource used and emission to the environment. And the last, it is also help to prevent the unnecessary resource waste, and it also has the higher opportunity of reducing environmental impact. For the Eco Web design, the Eco Web design enables a designer to quickly assess the natural influence of each component of a product. The component is rated on a scale ranging from generally good to generally bad, is the various eco design web categories. The Eco Web works by examining an item's 7 design spaces, which include material selection, material usage, circulation, item usage, optimum usage, and of life, and finally, better ways to do it. Equip design site assists in highlighting the item weakness so that it tends to be a chance. For the third one, eco indicator, the eco indicator is a method of measuring the life cycle. To assess the environmental efficiency of a product, it's necessary to calculate the eco indicator scores for the material process. Yes. There are 5 processes that must always be followed to ensure appropriate application of the eco indicator. Those are stabilizing the objective, producing a schematic overview, identifying a functional units, quantifying all relevant operation from the process tree, and making assumption for missing data. The last stage entails completing eco-indicator form by locating and inputting the eco-indicator values and interpret the data that combines. Lastly, the material analysis and their life cycle. The analysis of material and its life cycle is to potentially reduce the unwanted waste during the product manufacturing, as well as it also will help to preserve the natural resources. This method is about constructing a simple tabulation that consists of material classification.
Hello everyone, my name is Elizabeth SIBAT. I will present about our findings on electric kettle. Life cycle thinking process in this video consists of 15 components which are made from ferrous metal, non-ferrous metal, polymer, and natural rubber. The process begins with raw material extractions, then distribute to productions and undergoes process such as extractions, injections, molding, metal bending. The product then distributed to the retailer. At the end of the stage, most of the polymer and metallic materials are recyclable, and certain plastic components assumed to be landfill. Next, I will share about our findings on eco-web designs. As you can see here, we have gone through for each component of electric kettles to identify which part needed improvement. Material selection and uses of components we give good, since most of the components used are recyclable. Other than that, for distributions we give very good, as the product distribute use truck and packaging use more environmentally friendly packaging. Besides that, product use little energy during manufacture, it is designed and made to last. And optimal life for each component can be easily maintained with replaceable parts, and the material are durable, which is good. Product components have good end of life because can be recycled and reused. Unfortunately, certain components have bad end of life, which will cause landfill. Lastly, and ways of going it for product components mostly can be innovated. Next slide is eco indicator, which is split into two sections. The first section is about productions of raw material. The total obtained for productions before redesigns is higher than after redesigns due to the amount of raw material decrease. Second, the total of distributions electric kettles before and after redesigns is 334,402.96. The total of disposal after redesigns is higher than before, which is negative 128,047.5, because in life of plastic and metal distribute about 80% recycling, 10% for incinerations of plastic and metal, and another 10% assumed to be landfill. As the final results, when the material replaced with polymers such as polypropylenes or polycarbonate, we can say that the total values after redesigns decreased to 207,147.02. That's all from me. Thank you.
So good day, doctor. My name is DALGLISH. So for my part, I will present regarding the discussion of our product. There are four things that we discuss in this assignment. The first one is the improvement for the electric kettle. The second one is the product life cycle. The third one is the eco web design, and last but not the least is the eco indicator activity.
For the improvement for the electrical kettle, the aim is to redesign to extend the product life by protecting it from harm which caused by human and the environment. By using this method, the product lifetime can be extended on the hand. With this technique, the component can be continue function correctly for a long time. To achieve this thing, we can apply a protective cord to the steel object to prevent it from rusting. The polycarbonate indicator also include in the makeover. So the second one is the product life cycle. Life cycle thinking aim to reduce the resource consumption and the pollution while increasing the economic efficiency throughout the product life cycle. Life cycle method and the methodology for the modeling and helping in sustainable economic growth have been developed, optimized, and widely used in the private and the public sector. Next is the eco-web design. So the eco design site was created by dividing into sections. plastic manufacturing necessity the use of a large quantity of energy, notable heat and the electricity. We can also see an improvement in the product when we're using the design for environment approach. The evaluation for the new way of doing things, distribution and the ideal way life is both positive. So the next one, and last but not least, is the eco indicator activity. The eco indicator activity is simplified version of a life cycle assessment tool. It identifies the stage of the life cycle that have impact as well as where the item in the process is identified as contributing to the impact. The overall value after the makeover is 207,147 and 2. There is a rise in the overall value. That's all for me. Thank you.
And then here is the last part of our presentation, which is conclusion. In this conclusion part, I'll be concluding all the major points that we have presented before, and I'll be pinpointing all of them. Thank you. So that I would like to conclude this topic by saying and pinpointing a few points that we have presented before. For example, the first point would be the goal of this research is to assess the environmental impact of the electrical kettle manufacturing process. And the second point is the product design may always be improved and contribute to a more sustainable development strategy. And the third point is improving the product's life, reducing the amount of material used, and moving to a better material have all helped to achieve sustainable development. And the last point would be we also able to know the importance of the tools like LCA, life cycle assessment, eco web design, and where it plays like eco indicator and some other major role of all these to maintain the sustainability of a product. So all these points are the wrap up for the entire video presentation, and that's all from us. We would like to thank everybody those who are viewing this video. Thank you.